Dead End Like My Career room design. Commercially available recording equipment and software has led to the rise of bedroom artists and producers. A recording studio is no longer needed to record, produce, and mix an album that can achieve critical acclaim and garner an audience. Although not an ideal listening environment, a bedroom may be the only available space for young producers, artists, and engineers to work. Unfortunately, bedrooms are not designed with acoustics in mind. They are usually small and shaped closely to a cube to fit a bed and a dresser. There is overlap in room modes and no space to effectively treat low-frequency information. These all pose serious problems for anyone mixing their project in this space. The purpose of Dead End Like My Career, or DEMC, is to use characteristics of a bedroom in conjunction with live-end dead-end design elements in a cost-effective manner to minimize the effect of the room on the mix translation. The goal of Dead End Like My Career is to increase the clarity, flatten the decay response, and decrease the decay time to acceptable levels using diffusion and absorption techniques inspired by live-end dead-end room design. Unfortunately, there is not enough space or budget to create bass traps like a true live-end dead-end design. However, the advantage of bedrooms is the presence of dense, absorptive furniture and clothing such as closets and beds. A bed is a great low-frequency absorber that sits right behind the control room chair. It is large, dense, and porous to capture the low frequencies and act as a bass trap as well as a functional place to rest. The live end of the room is designed to have two diffusers accompanied by thin 2-inch foam panels to absorb frequencies above the diffuser's target bandwidth. 14 pieces of 2-inch by 2-inch by 8-foot lumber were cut by hand to the appropriate lengths and then sanded. The pieces were then glued to a 2-foot by 2-foot piece of 11/32 plywood. The diffusers had pressure applied and let sit to allow the glue to set. Finally, brackets rated for 45 pounds were mounted into the wall and to the backs of the diffusers for installation. The dead end of the room was designed to have an absorption panel that hangs off the wall behind the monitors. The frame for the panel was constructed from 1/2-inch PVC pipe. The lengths were cut by hand to allow the frame to fit in the 10 inches between the monitor and the wall snugly. The panel itself was 10.7 square feet of denim insulation wrapped in thick canvas. The denim insulation was chosen due to its effective sound absorption and safer handling in comparison to mineral wool or other fiberglass insulations. 1-inch layers of denim insulation were stacked on top of one another to create a 5-inch thick panel. This panel was hung by clip hooks and suspended by the PVC frame 5 inches from the wall. Using lambda equals V over F and the quarter wavelength air gap principle, it was found that the 5-inch air gap should be most effective at approximately 675 Hz. This attenuation of the low mids will be extremely helpful due to the problematic nature of that bandwidth in small rooms. The diffusers were designed using Acoustic Calculator. This software generates the appropriate pattern and lengths of blocks for the construction of Skyline diffusers. I made the target bandwidth of diffusion between 850 Hz and 4 kHz. This bandwidth is the most important for intelligibility, which is key to improving the clarity of the room. Room EQ Wizard was used to measure the effects of the acoustic treatment. Testing was first done with no diffusers or absorption in the room. After the appropriate equipment calibrations, a sine sweep response was captured using Yamaha HS8 monitors and an MXL 250 condenser microphone. The treatment was then installed onto the walls and PVC frame, and the same test was repeated. At 1 kHz, the decay time before treatment was 447 milliseconds. After the installation of the experimental design, the decay time was 357 milliseconds at 1 kHz. The decay time was reduced by 0.9 seconds at 1 kHz. In addition, the decay curve was flattened significantly between 500 Hz and 4 kHz. After treatment, the clarity increased from 18 decibels to 20.8 decibels. Dead End Like My Career achieved a flatter decay curve in the target bandwidth and increased the clarity between 800 Hz and 2 kHz. To better this design, further treatment should be explored to address low-frequency information in problematic room modes. There are clear rigid peaks from room modes present in the low mids of the T30 measurement. After these low-mid frequency room modes are addressed, the T30 decay curve will be even flatter across the spectrum. However, dead end like my career does effectively attenuate the room above 500 Hz, making it a viable acoustic treatment option for under $300 for any bedroom artist, producer, or engineer that has a handsaw and wood glue.